Trigonometry identities. The first identity we learn is sine square theta plus cos square theta equal to 1. Let me give you an example to show this. Now, suppose I have sine square 30 plus cos square 30. Sine square 30 is 1 by 2. Sine 30 is 1 by 2. So sine square 1 by 2 the whole square. Cos 30 root 3 by 2 the whole square. So 1 by 2 is 1 by 4. 1 by 2 the whole square. Root 3 by 2 the whole square will be 3 by 4. You take the LCM 4. 1 by 3. And you see it is 4 by 4, which is equal to 1. So sine square 30 plus cos square 30 is 1. This stands for all angles. Sine square theta plus cos square theta is always equal to 1. From here we can get two more expressions. Suppose I want to know what is sine square theta. Will be 1 minus cos square theta. So you got to remember this. I've just taken the cos square on the other side. Now what will be cos square theta? 1 minus sine square theta. The other things that you need to remember is that cosec theta equal to 1 by sine theta, or sine theta equal to 1 by cosec theta. Sec theta equal to 1 over cos theta, and cos theta equal to 1 over sec theta. Tan theta equal to 1 by cot theta, and cot theta equal to 1 by tan theta. Two more you need to remember is tan theta can be also written as sine theta over cos theta, and cot theta can be written as cos theta over sine theta. So we've learned the reciprocals. So which means when you get sine theta into cosec theta, you would do sine theta. Cosec is 1 by sine theta, and that always would be 1. So straight away when you have sine into cosec, you will put it as 1. Similarly, if you have cos theta into sec theta, they are reciprocals, and this will be 1. Why? Cos theta, sec theta is 1 over cos theta, so it will be 1. If we have tan theta into cot theta equal to 1, which means why? Tan theta and cot is 1 over tan theta, so it has to be equal to 1. So we do a little practice now. Suppose I do sine theta into dash equal to 1, or let's see cos theta into dash equal to 1, tan theta into dash equal to 1. What are you going to put here? So you know sine theta, the reciprocal of sine theta is cosec theta, so you will put here cosec theta. Sine theta into cosec theta is 1. Then cos theta into sec theta is 1. Tan theta into cot theta is 1. Prove 1 minus sine square theta into sec square theta equal to 1. First let us see what is 1 minus sine square theta. You knew sine square theta plus cos square theta was equal to 1. This is an identity. And cos square theta will be equal to, take the sine square on the other side, you will get 1 minus sine square theta. So 1 minus sine square theta, I can write it as cos square theta. This is into sec square theta. And now you know cos square into sec square is 1, because here we have cos square theta. For sec square theta, I am going to put into 1 over cos square theta. They cancel, equal to 1. Now let's go ahead and prove this relationship. So we take up first 1 over 1 minus sine theta plus 1 over, 1 is plus and 1 is minus, so this is plus here, minus sine theta. We have to prove it's equal to 2 sec square theta. We'll take LCM. So this will be the LCM. 1 plus sine theta, 1 minus sine theta. So you'll see that the numerator has to be multiplied now by 1 minus sine theta, because we're taking the LCM, plus 1. This numerator again will have to be multiplied 1 plus sine theta. Now you open the bracket, 1 minus sine theta plus 1 plus sine theta. And in the denominator, what have we got? A plus b, a minus b. 1 plus sine theta, 1 minus sine theta. That is a square minus b square. So we have plus and minus. This will cancel. So 1 plus 1 is 2 over 1 minus sine square theta. Now do you recollect what is 1 minus sine square theta? 1 minus sine square theta equal to cos square theta. You need to remember this. So you have 2 over, for 1 minus sine square theta, I am going to put cos square theta. Now yet another definition to remember. Now here we have 1 over cos square theta. Do you recollect what is 1 over cos square theta? Is sec square theta. So I will put here sec square theta. So 1 over cos square I'm going to put, and I have proved. So here I've used 1 over cos square theta equal to sec square theta. Next one, cosec square theta plus sec square theta equal to cosec square theta into sec square theta. Now do you remember what is cosec square theta? It was the reciprocal of sine theta. So for cosec square theta, I'm going to put 1 over sine square theta. And sec square theta was 1 over cos square theta. You got to write this in the reasons. Now it is time to take the LCM. Sine square theta, cos square theta. So we have the LCM here. Sine square theta into cos square theta. So the numerator here will have to be multiplied by cos square theta. And this numerator here will have to be multiplied by sine square theta in order to take the LCM. So in the numerator you will have now cos square theta plus sine square theta over, in the denominator, sine square theta into cos square theta. Now again we have an identity here, cos square plus sine square, and we know that is 1. I'm going to write it here. Cos square theta plus sine square theta is 1. So here equal to, I'm going to write 1 for cos square plus sine square. For this I'm going to write 1 over sine square theta cos square theta. So now here I got 1 over sine square theta cos square theta. Let me separate it out. That is 1 over sine square theta into 1 over cos square theta. Now do you remember what is 1 over sine square theta? it is cos x square theta. And what is 1 over cos square theta? Is sec square theta. So we have the answer, cos x square theta, sec square theta. So we prove the left hand side equal to the right hand side. Okay, now we need to prove sin theta over 1 minus cos theta equal to cosec theta plus cot theta. The sum is a little different, a different type of sum. So here we have 1 minus cos theta. I'm going to multiply it by 1 cos plus cos theta. So you got to write in the statements, multiplying the numerator and the denominator by 1 plus cos theta. So what happens now in the numerator is you have sin theta, and I multiplied it by 1 plus cos theta. And look up in the denominator, it's a minus b, a plus b. 1 minus cos theta, 1 plus cos theta. And a minus b into a plus b is a square minus b square. Please write this identity, this a plus b into a minus b is a square minus b square as your reason. So here 1, and this would be cos theta. So now I'm going to go ahead. So this is sin theta, you have 1 plus cos theta, and I got now 1 minus cos square theta. So numerator sin theta, I copy it as it is. Now if you look up very carefully at the denominator, it looks something that you have learned. 1 minus cos square theta. Do you recollect what is 1 minus cos square theta? Is sine square theta. So here I'm going to write sine square theta. So which is now sine theta, 1 plus cos theta. Sine square, for sine square I'm going to do sine theta into sine theta. So I cancel this out. Now what remains here is 1 plus cos theta over sine theta. Let me split this LCM. This is 1 over sine theta. I'm taking the LCM separately, plus cos theta over sine theta. Now if you remember, what is 1 over sine theta? Cosec theta. And what is cos theta over sine theta? If you remember, that is cot theta. You got to remember this, and you got to write it as a reason. Cos theta over sine theta is cot theta, and this is your plus. We have proved this. We go ahead and prove this. 1 minus cos square a into cosec square a. Now we have here 1 minus cos square a, and 1 minus cos square a is sine square a. This is, you need to remember. So we have here sine square a into cosec square a. Now if you remember, what is cosec square a? This sine square a and cosec square are reciprocal. So for cosec square a, I'll put 1 over sine square a, because cosec a equal to 1 over sine a. Now these two cancel out for the reciprocals, equal to 1. Now we need to prove tan square theta into cos square theta equal to 1 minus cos square theta. So we start with tan square theta into cos square theta. Now we are going to substitute for tan square theta. If you remember, tan square theta is sine square, tan is sine over cos. So tan square over cos square theta. So here for tan square, I'm going to put sine square over cos square theta. You got to write this in a reason, that tan is sine over cos into cos square theta. If you look very carefully now, I can cancel cos square and cos square, and I'm left now with only sine square theta. Do you recollect what is sine square theta? Sine square theta is also 1 minus cos square theta. Now why have I put this? Because see, I need to get 1 minus cos square theta, and I have got sine square theta, and I know sine square theta is 1 minus cos square theta. So I got my answer. The right hand side and left hand side are equal. This is 1 minus cos square theta. Prove cosec theta square root of 1 minus cos square theta equal to 1. Simple. It looks complicated, but it's very simple. So we have cosec theta, and in all these sums you need to remember your identities well. Once you do that, it's quite easy. Now, do you recollect what was 1 minus cos square theta? We've used this a couple of times. By now you should know. 1 minus cos square theta equal to sine square theta. So for this I'm going to write sine square theta for 1 minus cos square, and the others I just copy it out, and here is cosec theta. Now, so I'll write here now cosec theta. Under root of sine square theta, and you'll agree, is sine theta. Let me explain that. Under root of sine square theta means sine theta into sine theta, which will be sine theta. Now cosec and sine, you know, are reciprocal. So for cosec, I'm going to put 1 over sine into sine theta. This answer is 1. Next we need to prove tan theta plus 1 over tan theta is sec theta into cosec theta. So let's start with the left hand side. I have tan theta plus 1 over tan theta. So we have tan theta. Do you recollect what is 1 over tan theta? What is the reciprocal of tan theta? And 1 over tan theta, remember tan and cot are reciprocals. 1 over tan theta is cot theta. So here I'm going to write cot theta. Another thing now to recollect. Do you recollect what was tan theta again? Tan theta was also sine theta over cos theta. If tan theta is sine theta over cos theta, what would be cot theta? Cot theta will be cos theta over sine theta because they are reciprocals. So now for tan theta, I'm going to put sine theta over cos theta. And for cot theta, I'm going to put cos theta over sine theta. I'm going to take my LCM. This is cos theta, sine theta. So in the numerator, I have sine theta, and I'm going to multiply it by cos. So let's do that again. So my LCM is cos theta, sine theta. Now what is missing here? Sine theta. So numerator, denominator, both sine theta. So here I have sine theta into sine theta. On the other side, it was sine theta. I took LCM. So to make it sine cos theta, I need to multiply it by cos theta to get the LCM. So numerator also cos theta. So here I have cos theta into cos theta. Look up at the numerator. Sine theta into sine theta, sine square theta. Cos theta into cos theta, cos square theta, over cos theta, sine theta. Can you see an identity here? And this is the identity. You know sine square plus cos square. What is sine square plus cos square? Is 1. So in the numerator, I'm going to write 1 because cos square plus sine square is 1. Divide by cos theta, sine theta. I'm going to separate it out. So 1 over cos theta into 1 over sine theta. Now what is 1 over cos theta? Is sec theta. And what is 1 over sine theta? Is cosec theta. We have proved the left hand side equal to the right hand side. For the ninth one, prove cos theta over 1 minus sin theta equal to 1 plus sin theta over cos theta. Let's take the left hand side. So here's cos theta over 1 minus sin theta. So what I'm going to do for this one is 1 minus sin theta, you got to multiply it by 1 plus sin theta. A plus b, a minus b. Now whatever you do to the denominator, you need to do to the numerator so that the fraction does not change. So I've multiplied numerator and denominator by 1 plus sin theta. You got to write this in your reasons. So now in the numerator, I have cos theta, 1 plus sin theta. In the denominator, I have a plus b, a minus b, a minus b, a plus b, and that you know is a square minus b square. So here your a is 1 and your b is sin theta. We'll go ahead. So you have cos theta, 1 plus sin theta, 1 minus sin square theta. So now the numerator, cos theta, 1 plus sin theta. Now again, do you recollect what was 1 minus sin square theta? 1 minus sin square theta was equal to cos square theta. So in the denominator, for 1, instead of 1 minus sin square theta, I'm going to write cos square theta. Write this as your reason at the side. So now I have cos theta, 1 plus sin theta over cos square theta. So again, cos theta, 1 plus sin theta for cos square. So cos theta into cos theta. So I cancel this out. Now I'm left with 1 plus sin theta over cos theta. And I have proved the left hand side equal to the right hand side. Look up here. I have 1 plus sin theta over cos theta. Here is a similar sum for practice. In this we have to show the left hand side equal to the right hand side. So cos theta over 1 plus sin theta. In the denominator we have 1 plus sin theta. I'm going to multiply it by 1 minus sin theta. Numerator also I do the same thing. So in your reasons, in your statements, you got to write multiplying numerator and denominator by 1 minus sin theta. So you have cos theta, 1 minus sin theta. Now in the denominator, you have a plus b, a minus b, and that becomes a square minus b square. This would be 1 here and sin theta. So this is equal to now cos theta, 1 minus sin theta over 1 minus sin square theta. So this is cos theta. The numerator I copy as it is. Now do you recollect what is 1 minus sin square theta? By now you should know 1 minus sin square theta is cos square theta. Please write this in your statements. So here this is what I got. So you have cos theta, 1 minus sin theta. Down you have cos square. Denominator we have cos square theta. So that will be cos theta into cos theta. So here we cancel this out. We have 1 minus sin theta over cos theta, and we have proved it. Here 1 minus sin theta over cos theta. Now here we need to prove the left hand side equal to the right hand side. So here's my left hand side, and I'm going to multiply it just like the earlier sum. This is 1 plus cos theta. I'll multiply it 1 minus cos theta. Whatever I do to denominator, I have to do to the numerator so that my fraction remains the same. So next, look at the numerator. I have 1 minus cos theta and 1 minus cos theta. So I have 1 minus cos theta the whole square. Look at the denominator. It is a plus b, a minus b, which means it should be now a square minus b square. So a square minus b square. So I put 1 here and cos theta. Now we go ahead. This is under root. So I'll have here, I'll write this 1 minus cos theta the whole square over 1 minus cos square theta. Now again, I put the square root, I copy the numerator. Now for the denominator, by now you would have guessed I got 1 minus cos square theta. And what is 1 minus cos square theta? Is sine square theta. Now this is under root. If I want to remove the under root, 1 minus cos here square. So this will be 1 minus cos theta. This is 1 over sine square theta, would be just sine theta, and the under root gone. Now separate the LCM. So 1 over sine theta minus cos theta over sine theta. Now 1 over sine theta is cosec theta, and cos theta over sine theta is cot theta. Please write this in your reasons. So we've proved what they've asked us, cosec minus cot theta. Now for the 12th sum. So we need to prove left hand side equal to right hand side. Let us take up the left hand side. Look at the denominator. It is sine theta. So I multiplied this also by sine theta. Now why do I do it? As you keep doing the sums, you'll get the hang of how to do the sums. So here you have 1 minus cos theta into sine theta, and if you look at the denominator, is sine theta into sine theta, and this is sine square theta. So equal to 1 minus cos theta into sine theta. Now for sine square, here you know sine square theta equal to 1 minus cos square theta. So for this sine square, I'm going to put 1 minus cos square theta. So this is equal to now 1 minus cos theta, and this is sine theta. Now 1 minus cos square, I will use a formula of a square minus b square. So it will be a minus b and a plus b. I'll just do it up here. So 1 minus cos square theta will be a square minus b square. So it's a minus b, a plus b. And that's exactly what I'm going to do here. So 1 minus cos square, write 1 minus cos theta and 1 plus cos theta. In your statements, you got to write a square minus b square is a minus b, a plus b. Now here I can reduce this. So what I'm left now is sine theta over 1 plus cos theta. Now for the 13th one, again we need to prove the left hand side equal to right hand side. So let's write down the left hand side. It is sine theta 1 minus cos theta. Will you guess what you should do for this? 1 minus cos theta, I'm going to multiply it by 1 plus cos theta. This 2 1 plus cos theta. So your statements multiplying numerator and denominator by 1 plus cos theta. So in the numerator I get sin theta 1 plus cos theta. In the denominator a minus b, a plus b, a square minus b square. So 1, and this is cos theta. So now in the numerator sin theta 1 plus cos theta, and here I have 1 minus cos square theta. Let me open the bracket. So sin theta into 1 sin theta, sin theta into cos theta, sin theta, cos theta. Now what is 1 minus cos square theta? This bracket 1 minus cos square theta, you know, is sin square theta. In fact, here I should have not opened the bracket. I'll now just go back to this step. This step, there was no need to open the bracket. As you do the sums, you get to know. I'll keep it as it is. I'll keep sin theta so now you have sin theta 1 plus cos theta. Now in the denominator sin square theta, so it will be sin theta into sin theta. This would cancel out, so I get 1 over cos theta over sin theta. Now let's separate out the LCM. 1 over sin theta plus cos theta over sin theta. 1 over sin theta is cosec theta, and cos theta over sin theta is cot theta. So here again we need to prove the left hand side equal to right hand side. Let us take up the left hand side. So 1 plus sin theta over 1 minus, it is here, 1 plus sin theta. I'm going to multiply, this is a plus b, I'm going to multiply it by 1 minus sin theta. So this also 1 minus sin theta. So this is equal to, if you look at the numerator, is 1 minus sin theta and 1 minus sin theta. So it is 1 minus sin theta the whole square 2 times. In the denominator, a plus b, a minus b. 1 plus sin theta, 1 minus sin theta. So a square minus b square. So 1 sin theta. So here you have 1 minus sin theta the whole square and 1 minus sin square theta. Now the numerator, I keep it as it is, 1 minus sin theta the whole square. Now for the denominator, again it is 1 minus sin square. Now again we get this so often, 1 minus sin square theta, by now you should know, equal to cos square theta. So in the denominator I'm going to write cos square theta, because 1 minus sin square is cos square theta. Now there is square in the numerator and there is a square in the denominator. So I'm going to put a big bracket and put a square here. And so I'll put 1 minus sin theta over cos theta. Now again this big bracket of square for the both. I'm going to split the LCM up, 1 over cos theta minus sin theta over cos theta. So again whole square. 1 over cos theta is sec theta. Sin theta over cos theta is tan theta. And we've got our answer. So here we need to prove our left hand side equal to the right hand side. Let us start with the left hand side. Sin square a cot square a plus cos square a tan square a. So for sine square A, I write it as sine square A. Now for cot square A, do you recollect what is cot square A? Cot square A is cos square A over sine square A plus cos square, I write cos square A. Now you recollect what is tan square A, just the reciprocal of cot square, that is sine square A over cos square A. Now at this point I can reduce, here too I can reduce. So now what I'm left with is cos square A plus sine square A. And you know cos square A plus sine square A is 1, and we have proved. Here again we need to prove the left hand side and the right hand side. So we start with cot theta minus tan theta. Now cot theta is cos theta over sine theta, and tan theta is just a reciprocal. It is sine theta over cos theta. Now it's time to take the LCM. So here when I take the LCM here, this will be sine theta cos theta, and you'll definitely agree you'll have to multiply this by cos theta. So multiply numerator also cos theta to get sine theta cos theta. On the other side, cos theta you need to multiply by sine theta. Here too you need to multiply by sine theta, so that the denominator becomes cos theta sine theta. So we have now cos theta into cos theta minus sine theta into sine theta. So this is now cos square theta minus sine square theta over sine theta cos theta. At this point, just see where we need to go. We need to get this part. The denominator we have already got. Now problem is the numerator, and if you observe the numerator here, there is only cos square theta, there is no sine square theta. So what I'm going to do, for this sine square theta, I'm going to put 1 minus cos square theta. So I have now cos square theta minus, for the sine square theta I'm putting 1 minus cos square theta, because sine square theta is 1 minus cos square theta. And why am I doing this? Because in the numerator I have noticed there is no sine square theta, there is only cos square theta. So I have sine theta cos theta. Now I open the bracket, so this becomes cos square theta minus 1 minus to minus plus cos square theta over sine theta cos theta. Cos square is 2 cos square theta minus 1 over sine theta cos theta, and I have proved left hand side equal to right hand side. So at times you got to observe your right hand side, see what they need, and accordingly substitute in your sum. Like in this case we saw that the sine square theta was not there in the result that we needed, so we had to get rid of the sine square theta by putting 1 minus cos square theta. Now it's a similar sum. So we start with tan theta minus cot theta. So we know our tan theta is sine theta over cos theta minus, and the cos theta cot theta is cos theta over sine theta. Now we'll take LCM, and the LCM here is cos theta into sine theta. Now to get the LCM we need to multiply this first fraction into sine theta, because remember our LCM is cos theta into sine theta. So this is cos theta, here we have to multiply both by sine theta. And here we have sine theta, we got to multiply by cos theta. So here we have now sine theta into sine theta, and here cos theta into cos theta. So sine theta, sine square theta, cos theta, cos square theta over cos theta, sine theta. At this moment, let us take a look at what we need. Here, if you check up, the denominator is fine. This cos theta, sine theta, here cos theta, sine theta. So it is fine. Let's check up the numerator. In the numerator, there is only sine theta. But here, therefore, this cos square theta we have to get rid of. We have to put for cos square theta 1 minus sine square theta. So here for this we'll put 1 minus sine square theta. Then in the numerator we'll have only sine square theta. So let's go ahead and do that. So we have sine square theta minus, now for cos square theta I'm putting 1 minus sine square theta, because I have seen that in my answer in the numerator I require only sine. There should not be cos there. So over cos theta. Now open the bracket. Sine square theta minus 1 plus sine square theta over sine theta cos theta. Sine square 2 sine square theta minus 1 over sine theta cos theta, and we've got it. Here again for the 18 sum we need to prove the left hand side equal to the right hand side. So let's write down the left hand side. So here is the left hand side. Now if you notice in the numerator I can take sine A common out. So in the first term if I take sine A common out, 1 remains here, and then the second term will be 2 sine square A, because if you notice in the second term there is sine cube A and I took 1 sine, so square will remain. In the denominator I'm going to take cos A common out. So here you have cos cube, so when 1 cos A goes out, what will remain is cos square A minus 1. Now in the next step I'll write this as sine A over cos A, 1 minus 2. Now for sine square I'm going to put 1 minus cos square A, and I'll write the denominator as it is, 2 cos square A minus 1. Now next, sine A over cos A, open the bracket, 1 minus 2, minus into minus plus 2 cos square A. Denominator I write as it is, 2 cos square A minus 1. Now let's do it further. Sine A over cos A. Now here I have 1 minus 2, and 1 minus 2 you know is minus 1, plus 2 cos square A over denominator 2 cos square A minus 1. I can cancel this, but let me rearrange this to make it more simple. Sine A over cos A. Look at the numerator. I can write it as 2 cos square A minus 1. I have just rearranged it, and this is 2 cos square A minus 1. So I need to cut this out. So we have sine A over cos A. And what is sine A over cos A? Is 10A. So this sine A over cos A is 10A. So we have proved the left hand side equal to the right hand side. The key of the sum is at this point. For this sine square, you need to put 1 minus cos square and just keep opening the bracket. Here at the first step also, wherever you can take common out, that's the first thing you must do. Take common out and then proceed with your sum. Now for the 19th, again we need to prove the left hand side equal to right hand side. So let's copy up the left hand side. So here's the left hand side. It's time to take the LCM. And the LCM is sine theta. So here you get first term will be cosec theta. Now if you notice here it's over 1. So you need to multiply over 1. So into sine theta into sine theta, because the LCM is sine theta. So minus cosec theta into sine theta plus. Here again it is over 1. You have to make it sine theta. So into sine theta into sine theta. So here too you will do sine theta into sine theta. Now again I'll just write the LCM first. This is sine theta. And the first is cos square theta. I write it as cos square theta. Now do you remember what is cosec into sine? Cosec into sine is 1 because they're reciprocals of one another. So here, right? Now this is sine theta, this is sine square theta. I'm just putting things together, I'm just rearranging it. So cos square theta plus sine square theta minus 1 over sine theta. Now cos square plus sine square, this cos square plus sine square is 1. And this is minus 1 over sine theta. So 0 over sine theta, and that is 0. So again, just to go over some parts of it. Now remember this was 1. Why was this 1? Because you had cosec theta and sine theta. Sine theta is 1 over cosec theta. They're reciprocal. So this cancels out and you got 1. Next important point you have to remember was this. Cos square plus sine square. This cos square plus sine square is 1. That's how you wrote this one. So 1 minus 1 came 0. Here again we need to prove the left hand side equal to the right hand side. So let's copy the left hand side. So first step we take the LCM. And if you notice the LCM will be cos theta into 1 plus sine theta. So cos 1 plus sine theta. Now the LCM is cos theta into 1 plus sine theta. So here I need to multiply this 1 plus sine theta to get the LCM. And whatever I do to the numerator, I do to the denominator. So here too I need to multiply 1 plus sine theta. Now here in the next fraction is 1 plus sine theta. I need to multiply it by cos theta to get the LCM. So here also cos theta. So here I have now 1 plus sine theta, 1 bracket, again 1 plus sine theta. Here I have cos theta, cos theta, cos square theta. So I have 1 plus sine theta and again 1 plus sine theta. So this will be 1 plus sine theta the whole square plus cos square theta over cos theta 1 plus sine theta. Now in this bracket I'm going to use the formula a plus b the whole square, 1 plus sine theta the whole square. So a plus b the whole square, a square, b square, 2ab. So that is 1 sine theta, b square, ab, 1 sine theta. That's what I have done in this. I applied the formula a plus b the whole square, and this is my cos square theta. The rest I have copied as it is. Now 1 square is 1, this is sine square theta. 2 into 1 into sine theta is 2 sine theta plus cos square theta over cos theta 1 plus sine theta. Now I'm going to club things together, just rearrange. This is sine square and this is cos square, and I'm going to put them together because I know sine square plus cos square will give me 1. So 1 plus, I'm putting these two together, sine square theta plus cos square theta, and here 2 sine theta over cos theta 1 plus sine theta. Now for sine square plus cos square I'm going to use 1. Okay, so let's go ahead. 1 plus sine square cos square, I will put 1, so I put 1 here, plus 2 sine theta over cos theta 1 plus sine theta. So 1 plus 1 is 2, plus 2 sine theta over cos theta 1 plus sine theta. Now look up in the numerator, I can take 2 common out. So here is a 2 and here is a 2. So this 2 I will take common out. What remains inside is 1 plus sine theta, the 2 is out, over cos theta 1 plus sine theta, and I'm getting close to it. 1 plus sine theta, 1 plus sine theta, I cancel out. So this is 2 over cos theta, which means 2 into 1 over cos theta, which is 1 over cos theta is 2 sec theta, and that's what we needed to prove, equal to 2 sec theta.